How now shall we live? God said, "Let there be light." Understanding the origin of the universe is the starting point of all worldviews. However, the first question in exploring the origin of the universe is whether the origin of the universe really exists. Whether the universe has no beginning or no end or has a beginning is a dividing line in the field of cosmology, like an obvious crack in the magnificent and solid castle of science. It is this crack that allowed Dave, a father who entered the scientific battlefield alone, to find a breakthrough in his first battle. In the historical process of human scientific development, ancient Greek philosophical thought has long occupied a dominant position. One of them is Aristotle's cosmological eternity theory, which holds that the universe is eternal in time, with no beginning and no end. The basic components of the universe, such as matter and energy, are also eternal and will not appear or disappear out of thin air, but will transform between different states. The cosmological eternity theory is the philosophical basis of the static universe model, and even Einstein once believed it firmly. In November 1915, Einstein published the famous Einstein gravitational field equation at the Prussian Academy of Sciences. This equation became the core of Einstein's general theory of relativity. In 1917, Einstein applied general relativity to the study of cosmology. According to the gravitational field equation of general relativity, the universe should change dynamically, or expand or contract, rather than be static. In order to conform to the belief in a static universe, Einstein added a new cosmological constant to his gravitational field equation to introduce an anti-gravity effect to counteract ordinary gravity, thereby keeping the universe static as a whole. However, this cosmological constant made Einstein miss the Big Bang theory, which became his biggest regret. The Big Bang theory is a widely accepted theory in modern cosmology that explains the origin and evolution of the universe. According to this theory, the universe originated from a singularity about 13.8 billion years ago, and then underwent a process of rapid expansion and evolution. The so-called singularity is a point with a theoretically infinitely small volume, extremely high density and temperature. At the moment when time was zero, the universe began to expand extremely rapidly, called the Big Bang. As the universe expanded, the temperature gradually decreased. In the initial stage of expansion, the basic structure of matter, energy, and space began to form. About 1 second after the Big Bang, the temperature of the universe dropped enough to form elementary particles such as protons and neutrons. A few minutes later, the lightest atomic nuclei, such as hydrogen, helium, and trace amounts of lithium, were formed. About 380,000 years after the Big Bang, the universe cooled enough for electrons to combine with atomic nuclei to form neutral atoms. At this time, photons broke away from matter and formed the cosmic microwave background radiation, which is an important evidence for the Big Bang theory. After hundreds of millions of years, matter gradually gathered under the influence of gravity to form stars, galaxies, and larger-scale cosmic structures. The Big Bang theory was born out of the great contributions of many scientists, most notably Albert Einstein. His theory of general relativity provided a theoretical framework for describing the overall structure of the universe. Unfortunately, due to the influence of the eternal universe view, he missed the opportunity to propose a dynamic universe model. At the crossroads where Einstein lost his way, Russian mathematician and physicist Alexander Friedmann chose the right direction. In 1922, based on Einstein's general theory of relativity, Friedmann derived the Friedmann equations that describe the evolution of the universe and established the Friedmann cosmological model. The Friedmann equations provide a mathematical basis for the dynamic evolution of the universe and are widely used in modern cosmology. Friedmann's model suggests that the universe may have a starting point, which contrasts with the eternal static view of the universe. However, Friedman's work was not widely accepted or valued during his lifetime, and even Einstein initially believed that his solution had no physical significance. In 1925, Friedman died of typhoid fever and did not live to see his theory confirmed. The first scientist to clearly propose the Big Bang theory was Georges Lemaitre. Lemaitre was a Belgian astronomer, physicist, and Catholic priest. After studying at Cambridge University and Harvard University, he received his doctorate from MIT and had in-depth research in astronomy and general relativity. He was both a scientist and a religious person, which enabled him to explore the origin of the universe from a scientific and philosophical perspective. In 1927, Lemaitre published a paper proposing for the first time that the universe was not static, but expanding. He used the mathematical tools of general relativity to derive a formula for the expansion of the universe. This formula later became known as Hubble's law, although Lemaitre's paper predated Edwin Hubble's related work. In 1931, Lemaitre proposed the primordial atom hypothesis of the origin of the universe. He believed that the universe originated from an extremely small, dense, and hot state, the so-called primordial atom. This primordial atom, due to its inherent instability, had a Big Bang, releasing all matter and energy and began to expand. This theory laid the foundation for the modern Big Bang theory. Lemaitre's theory did not receive widespread attention at first, but later gained attention due to Hubble's observational evidence. Lemaitre's work showed that the universe had a beginning, a conclusion that had a profound impact on philosophical and religious concepts. Lemaitre was not only one of the founders of the Big Bang theory, but also a pioneer in combining mathematics and physics in cosmological research. His theory became the cornerstone of modern cosmology and influenced the subsequent development of cosmology, including the theory of cosmic inflation and the study of dark energy. In 2018, in order to commemorate Lemaitre's contribution, the International Astronomical Union renamed Hubble's law as the Hubble-Lemaitre law. Any scientific theory that has not been verified by experiments can only be a scientific hypothesis. The Big Bang theory must also be verified by astronomical observations. At this time, another scientific giant appeared on the scene. He is Edwin Hubble, who is known as the father of modern cosmology. He observed the phenomenon of cosmic expansion and provided decisive evidence for the Big Bang theory. Hubble initially studied law, then switched to astronomy and completed his doctorate at the University of Chicago. He worked at the Mount Wilson Observatory in California, using the 100-inch Hooker telescope, the most advanced telescope in the world at the time. In 1929, Hubble and his assistant Milton Humason used spectroscopy to measure and found that the spectral lines of many galaxies were moving toward the red end, which was called redshift. Hubble derived Hubble's law by analyzing the relationship between redshift and galaxy distance. This discovery showed that the universe was expanding and supported the theory of a dynamic universe. Hubble's discovery provided observational support for the cosmic expansion model proposed by Friedman and Lemaitre. 20 years later, a new milestone was reached in the development of the Big Bang theory. In 1948, George Gamow, Ralph Alpher and Robert Herman predicted the existence of cosmic microwave background radiation. In short, the universe was filled with high-energy radiation in the early days of the Big Bang. As the universe expanded, the wavelength of this radiation lengthened and the temperature dropped, forming observable microwave background radiation. The cosmic microwave background radiation is one of the strongest evidences for the Big Bang theory. However, due to the lack of verification by astronomical observations, this prediction did not receive widespread attention at the time. The search for the cosmic microwave background radiation was a dramatic one. Arno Penzias and Robert Wilson were two American physicists working at Bell Labs. In 1964, they used a Holmdel-Horn antenna, a satellite communication antenna, to measure radio signals in the radiation from the Milky Way. In their experiment, they found a stable background noise that was always present no matter which direction the antenna was pointed. They tried to eliminate various sources of noise, including thermal noise from the antenna equipment, radio interference from nearby cities, and even cleared the antenna of bird droppings. However, the signal was still there, manifesting as an isothermal microwave radiation field. Penzias and Wilson contacted the team of Princeton University physicist Robert Dicke, who was trying to find the cosmic microwave background radiation predicted by Gamow and others. When Dicke learned of Penzias and Wilson's discovery, he said, "They have found what we are looking for." Penzias and Wilson jointly won the 1978 Nobel Prize in Physics for their discovery of cosmic microwave background radiation. Their work is hailed as one of the most important scientific discoveries of the 20th century. The verification of rigorous theories and astronomical observations has made the Big Bang theory the mainstream view in the field of cosmology. Scientists continue to make new contributions to the development of the Big Bang theory in terms of theory and astronomical observations. The Big Bang theory has changed the human view of the universe from static eternity to dynamic evolution, and has changed our understanding of time, space, and matter. It shows that the universe has a beginning, and has inspired philosophical and theological thinking about what was before the universe and what is outside the universe. Back to our story, Dad Dave was very excited when he saw the grand picture of the universe presented by the Big Bang theory. It turns out that the development of science has not only failed to destroy the Christian faith, but has strongly supported the biblical view of the universe. The universe has an ultimate origin. It began from a singularity that humans cannot recognize, and the rapid explosion from the singularity and the subsequent long expansion evolution formed the universe we can observe now. Thank you for watching this video. The topic in the video is from Chapter 7 of Charles Colson's Golden Award-winning book, How Now Shall We Live? Links to some of Charles Colson's books are listed below the video. May God bless you.